I'm Edward B. Kang, and I'll be starting as an assistant professor of critical digital studies at New York University in the fall. This paper, titled On the Politics and Praxes of AI Speech Emotion Recognition, examines how the complex ontologies of emotion are technologically reconciled within the epistemic bounds of machine learning, specifically in the context of AI speech emotion recognition, or SER. Dr. Bjorn Schuler defines speech emotion recognition as the discipline of automatically recognizing human emotions and affective states from speech. It's important, however, to take a step back and instead of just assuming that we know what emotion means in SCR, we need to seriously consider the fundamental question that underlies that definition. What is emotion and how does one know or hear it? Well, it turns out that no one knows. No one can agree on what emotion really is. These are two broad categories of emotion theories that are invoked in psychology literature, but there are so many variations of these and more. Basic emotion theory is the most simplistic model of emotion popularized by people like Paul Ekman, and it's been heavily critiqued for its reductiveness. This model sees these six emotions, sometimes the number changes, but the premise is the same, as biologically hardwired and therefore universal across humans. James Russell is one of the greatest critics of this notion. He says that basic emotion theory is ultimately a folk theory made scientific. So if we consider, for instance, the fear we might feel suddenly encountering a bear in the woods, that fear is very different from the fear someone who paid to watch a horror movie in the theaters might feel. So Russell appropriately asks, what other than the label fear do various instances of fear share with each other that they do not share with what is not fear? There may be no one scientific model that applies to all cases of fear and only to fear. Instead of emotion, Russell proposes a dimensional model of core affect that orthogonally maps valence, positive versus negative, activation, also sometimes referred to as arousal, and dominance, how in control someone feels of the situation, in a three-dimensional plane. In the interest of time, I'm not going to delve much deeper into this, but the key point for our discussion is that this is a model that was proposed out of a dissatisfaction with the simplicity of discrete emotion theory. It's proposed as a model that can accommodate emotional descriptors without being bound to the label as a fixed and universal ontology. This ontological complexity of emotion is important because for emotion to be made legible to a machine learning system, it needs to be bounded, defined, and instantiated as ground truth. This table is from Rosalind Picard's book Affective Computing, and here she asks, what is a good computational mapping between emotions and speech patterns? As you can see in the columns, the ways that emotion is taxonomized is through the categories given in basic or discrete emotion theory. As Florian Jeton has written about, once a particular ontology is accepted as a usable ground truth or taxonomy in ML, it serves as the bedrock for further studies, benchmarks, and evaluation metrics. It entrenches itself as the default way of framing a particular task. We see that this is definitely the case for the numerous SER-related studies that followed Picard's mapping over the next decade, starting with his paper in 1996. In contrast to Picard, who only conceptualized these mappings, Dallaire et al. Actually needed to physically produce emotion for their emotion recognition system. For this, they used actors who were given scripts associated with emotional labels and asked to read the script with that emotion. They write in the methodology paper that the actors were instructed to base their performances on a framework called believable agents, which is actually a term coined by computer scientist Joseph Bates based on a philosophy of animation developed by Disney artists in the 80s. You can read the full paper for a more detailed description of how this Disney philosophy was adopted. What's important here is that various different adaptations of this staged method of categorical emotional performance still comprises the primary way that emotional ground truths are constructed for SER today. This is a list of the top 10 most cited open source SER datasets that I examined along with their accompanying methodology papers, all of which use actors to produce the emotional expressions. Broadly, the actors follow two methods of emotional performance: one, communication effect acting, or CEA, and two, felt experience acting, or FEA. CEA is when an expressor produces an emotion specified by an emotional label in a way that the expressor and the recorder believe optimizes the recognition of the emotion by external observers. For example, an actor is given a sentence or phrase and asked to say that phrase in an angry way, and that becomes an instance of angriness in the dataset. So this obviously runs into generalizability problems. One person's angriness is specific to that person and situation, both in terms of its expression and its perception. So to give you an example of how silly these can get, here's an example of an that was produced for the MAV dataset with the instructional label of angry.
Ah!
FEA tries to address this limitation of lack of authenticity by implementing what actors might call method acting, or the use of vivid mental imagery techniques so that expressors can recall personal past events when they felt the target emotion. Here's a photo from the Emo Cat methodology paper that shows how these emotional elicitations were captured. Apparently, having 8 cameras in your face is a great setup for eliciting authentic emotional expressions. A non-trivial aspect of this methodology, however, is the IRB. Because this would be considered human subjects research, which requires the study facilitators to make sure there's no psychologically disconcerting experiences for the participants, the question is, how do you ethically elicit psychologically disconcerting emotions such as anger, fear, or sadness? This is never addressed in the methodology papers. Essentially, what they need to do is frame the elicitation process in the IRB protocol as not really psychologically disconcerting, which then raises the question, how authentic is FEA? It doesn't actually address any of the limitations of CEA and its performativity. Ultimately, the limitation of both FEA and CEA is that an emotional expression is always just an instance of emotion tied to the context of production, a production that is heavily guided and designed by the creators of the dataset. A woman reading a sentence accompanied by the label joy in a way that both she and the study facilitators perceive to be joyful might indeed be an instance of joy, but it doesn't represent a generalizable representation of joy neither within nor across subject. This is true regardless of whether it's a product of a script or an authentic elicitation. One of the primary commercial use cases for SER is call center optimization. Cogito is the biggest name in this space. They monitor conversations between call center operators and customers and analyze acoustic voice signals to give agents cues on how to adjust their behaviors. In an interview, the company's COO stated that positive emotional evaluations of agents by its SER system boosts agents' chances of performance-related bonuses. The flip side of that, of course, is a performance-related penalty related to behaviors that might be categorized as a negative emotional evaluation. This means there's an explicit link between emotional regulation and worker compensation facilitated through an SER system that functions as a surveillance tool that constantly monitors operators' conversations. Here, operators are seen through a dehumanizing lens akin to what Jeff Nagy describes in the context of autism mitigation programs and facial emotion recognition, where autistic individuals are understood as a modular assemblage of adjustable behaviors that can be reoriented to fit a conversationally productive and desired normal. A normal that, as I stated earlier about SER datasets, is a narrowly defined set of emotional caricatures. For Cogito, the workers now have the additional labor of making themselves legible and desirable to the data structures newly entwined in their performance reviews. Sarah Rose documents how disability was a concept that was invented in the 19th century as a byproduct of the wage economy, when employers began to use pre-employment screenings to eliminate people deemed inefficient, non-productive, and likely to require extra help and support. In this history, the lack of ability to conform to particular notions of productivity effectively rendered an individual disabled, thereby disqualifying the person from participating in the workplace and earning a living. Cogito's use of SER as a mode of worker surveillance continues this history of ableist workplace politics, in which its subjects are problematically located on an expanded spectrum of emotional suspects that require constant monitoring and validating. In this way, Cogito's SER can also be interpreted as a disabling technology that transposes the systemic oppression of disabled individuals onto its users. To be clear, this is by no means to argue that the systemic oppression of disabled people should be contained, but rather the opposite. It's to problematize the deficit model of disability and neurodivergence altogether, so as to argue that such ways of thinking ultimately make such oppressive structures more widespread. I believe we're at a critical junction in the development of SER because it's at the cusp of being widely adopted in higher stakes contexts. Similar to the way that facial emotion recognition was recently dropped by Microsoft due to its tenuous scientific foundations and risks associated with high stakes applications, we should also understand SER within the same context. The ML community has a tendency to position ML as an all-encompassing solution. It recruits complex problems and simplifies and distills them down to the point that they fit and make sense within its classificatory framework. In this paper, I sought to shed light on the complications that occur in this process of distillation or translation in the context of speech emotion recognition. Thank you for listening.